Hello students, today we are going to learn about Regula Falsi method. Okay, so this is a sort of numerical method and category is engineering mathematics. Okay, so this Regula Falsi method is particularly used to find the approximate roots of a function. Okay, for example, suppose there is a function y equals to fx. This is y-axis, this is x-axis, and this is the curve of that function y equals to fx. Okay, then we know this thing that root is the point where y becomes 0. So in case by other methods we cannot find out the root, then we go toward this numerical method. So one of the method is this Regula Falsi method. Okay, so before understanding this, we will see an animation to learn the principle of Regula Falsi method. Now suppose that there is a function y equals to fx and whose curve is this, you can see. Okay, and this is xy coordinate system. So the root of this function is at the point where y becomes 0. This is the root. When y becomes 0, the value of x is what the root of this function is. Okay, now in case I am choosing 2 points on this curve, one in positive side of y and one in negative side, you can see a, b and c, d are at either sides of this x-axis. Okay, now this line, this red line is intersecting this curve at point CD. Now in case I am fixing this point AB and turning this line about this point AB, means making this AB point as pivot and then turning in clockwise direction, then the point of intersection of this line with the curve will also shift toward left. Okay, so ultimately in case I am turning it, that point of intersection is coming closer to this root. Okay, you can see it is coming closer. Ultimately, it is very closer. Okay, this is what the principle of Regula Falsi method. So let's learn how it works to find the approximate root of a function. Okay, now we will learn the Regula Falsi method by the help of solving a question. So the question is, determine the approximate root of the equation y equals to e to the power x plus x with an error of plus minus 0.20. Means, however, the root of this function will be when the y becomes 0, what is the x? Means for what x the y becomes 0. Still, suppose plus minus 20 is the error allowed in this analysis. Okay, so we have to find the approx root of this equation. So let's proceed. See, this is our function. Okay, and suppose this is the curve corresponding to that function. Okay, now we know this thing that the root of the function, as the curve is showing, the root of the function is over here where y is 0. This is y-axis, this is x-axis. So where y is 0, the value of x is what the root of the function is. Okay, now stepwise we will learn. The step number 1 is guess two numbers on the curve. They must be on the curve for which y is positive for one number and negative for other. So suppose I guess that x equals to 1 and 2. So in case I put x equals to 1 over here, I am getting y to be 3.718, and in case I am putting x equals to 2, I am getting y to be 9.389. So this is wrong guess. Reason being, I have to guess such type of numbers for x for which for one number the y must be positive, for other it must be negative. Now second guess, I am taking x equals to 1 and x equals to minus 5. So x equals to 1, I am getting y equals to 3.718, and for minus 5, in case I am putting in this function, I am getting minus 4.993. So this is a correct guess, means for one x the y is positive, for other it is negative. Okay, now the 2 points are 1 and 3.718, which must be in this first quadrant, and other minus 5 and minus 4.993, which must be in third quadrant because both are negative. Okay, now join the 2 points by the help of a straight line. These are the 2 points and I have joined those points by the help of straight line. Okay, now this straight line will have its equation. We know this thing that straight line equation is given by y equals to mx plus c. Okay, so what is m? M is y2 minus y1 upon x2 minus x1. So y2 minus y1 is minus 4.993 minus y1 3.718, and in the denominator minus 5 minus 1, that is equals to minus 6. So ultimately I am getting m to be 1.451. So equation of line will be y equals to 1.451 x plus c. To find the c, what we have to do? We know this thing that for x equals to 1, y is 3.718. So putting these values, y equals to 3.718 and x equals to 1, I am getting the c equals to 2.267. So putting the value of c in this equation, finally this is the equation of this straight line joining these 2 points. Okay. Now this straight line is intersecting with x-axis over here where y is 0. Over here it is intersecting with x-axis. Can you tell what is that point? Simple. Put y equals to 0 over here, you will get x. So over here it is. So this is our step 3. Put y equals to 0. So I am getting x to be, I am getting minus 1.562. Okay. Now for this minus 1.562x, in case I am putting in this equation, I am getting y to be minus 1.352 after putting this x in this equation. So it means since this x is kept in this equation, so the point on this curve is equals to minus 1.562 and y equals to minus 1.35. Okay, now join this point with this point and form a new line. So this is our line 2, this purple line 2. Okay, now we can see that this line is closer to the root. We have shifted toward right. Okay, so again we have to follow the step 2 and 3 for this line. Again this is a sort of iteration. So for this line the equation is again y equals to mx plus c. M would be y2 minus y1 upon x2 minus x1. So I have already calculated m equals to 2.049. So y equals to 2.049 x plus c. Now how to find c? Since for x equals to 1, y is 3.718. So putting those values, I am getting c equals to 1.814. So the equation of the line 2 is equals to y equals to 2.049x plus 1.814. Again, this second line also intersects the x-axis over here where y is 0. So how to find out value of x over here? Simple. Put y equals to 0. So putting y equals to 0, x comes out to be minus 0.885. Okay. Now in case I am putting this minus 0.885 in this equation, x to be this, what y I am getting? I am getting y to be minus 0.472. So in this curve, this point means when x is equals to minus 0.885, the y is equals to minus 0.472. Okay, now again I can draw line 3 which is much closer to this root. You can see root is over here. So this is line 3, yellow line. Okay, now again we can find the equation of this yellow line. So that will be y2 minus y1 upon x2 minus x1 will be the m. So y equals to mx plus c. M I have already calculated 2.222. So y equals to 2.222 x plus c. How to find c? Again this point when x is 1, y is 3.78. So putting the values, c is equals to 1.496. So y equals to 2.222 x plus 1.496. Okay, again where this third line is intersecting the x-axis where y is 0, putting y to be 0. So what x I am getting? X equals to minus 0.673. Now in case I am putting this value of x in this equation of function, I am getting y to be minus 0.162. So we have reached to our goal, that is y can have error of plus minus 0.20. Here it is. Okay, so y is almost closer to 0. So since in the question it is given that y can be between plus minus 0.20, so we have reached our answer. Still, in case you want more accurate answer, then you can again make line 4, again form the equation, repeat step 2 and 3. In that case you will find y more closer to 0. So by this way, by this iterative action, ultimately we can find the root of a equation and we can increase the accuracy by number of times we are performing the iteration. Okay, so this is what Regula Falsi method is. This is an iterative method to find the approximate roots of functions. Thank you.